So it should be starting to record. And there it goes. Okay, so we have a piecewise function. We are supposed to find the limit as x approaches 1. We're going to find the right and the left-hand limits to begin with. So I am going to start with this branch says it's 2 less than 1, which would be the left branch. Okay, so I am going to, that seems really narrow. Okay. I am going to start by putting this into this 3x plus 2. So the limit as x approaches 1 from the left of 3 of f of x, actually is probably the better way to actually officially state that. And that would be 3 times the 1 I'm substituting in plus 2, which is 5. Okay. Let me finish this part and then I got to talk about multiple choice or free response. Then this is going to be your right hand limit. So the limit as x approaches 1 from the right of f of x equals, and I'm going to plug into this branch. So 2 times 1 squared minus 3 times 1 plus 6. All right, 1 squared is 1 times 2 is 2. Negative 3 times 1 is negative 3. Plus 6, and 2 minus 3 is negative 1, plus 6 is 5. So our goal was to make sure that these matched. We met our goal, okay? But we have to make an overall statement that says what the limit is, because we've only stated about the left-hand limit and the right-hand limit. So you're going to say, therefore, the limit as x approaches 1 of f of x equals 5. It does say that you have to justify your answer. The justification is all this. So the idea behind this question is that we are simulating what a free response question looks like on the actual AP test. Okay, a free response question typically has between 3 and 4 parts. Very rarely are there 2. On the AP test, each free response question is scored as 9 points. I will simulate that. Usually my problems are worth 50, so I might simulate that into scaling it up to each part is worth however many of the 50 points, okay? And typically when we start studying for the test, there's scoring guides, so this part would be worth something that's like 3 points, okay? I'd give you 1 point for the left, 1 point for the right, and I give you 1 point for the answer. Now, if all you gave me was the answer, you'd only get 1 point, okay? It is up to you when you are taking the test this time. If you'd like to write this on your paper by hand, which is, I encourage that, okay, I will grade it off that. In the answer in there, just type in C paper. I will know to go grade it off the paper, okay? You're welcome to try to type it in, but that might take more time. And remember, you're on a timed test, and because you might not be as comfortable with the typing, like getting this guy in there the right way, might take you a little bit more time. So I would highly, highly recommend using the time, or just writing it on paper and saying C paper, and I will grade it from there. Okay. So, but it's up to you. If you want to type it, that's fine. Okay, as long as I see your work. Okay, and this thing here with the justification, it makes it a lot harder to copy. Okay, so you need to make sure that you are, and a lot harder to get all the steps from something that automates it. Okay, that's just the way it is. So the next thing it's asking is it continuous? Okay, so in order for it to be continuous, there's a couple of things that have to happen. So the first thing we have to show is we have to show that the limit as x approaches whatever this is, in this case 1, exists, okay, which we know that from part A. We have to show that f of whatever the value is exists. I didn't need an equal sign there. And then we have to show that the limit as x approaches 1 equals the limit of whatever it is. Okay, so if we have to show those things. I really should have used an A in here in general. The 1 is specific to the problem, okay? So I am going to go ahead and I'm going to do the arithmetic for f of a just to show its existence. So that will get me the point on that piece. So I'm going to say that f of 1 equals, and so I'm going back to this piecewise function. I see the equal to 1 here, so I know I'm plugging into this. And this seems super redundant because we've already done this calculation, but you haven't shown it to me with this notation or label on it, because we already know that it's 5. So we have shown me already in the previous part that, hey, the limit exists. Hey, now I know f of 1 exists. I know that they're equal. I need to state all of that now, okay? So is it continuous? The answer to the question is yes, okay? Because you're going to write out the word because. F of 1 exists. And the limit as x approaches 1 of f of x exists. And so there's the third thing, okay? The limit as x approaches 1 of f of x equals f of 1. All right, let me show you how I would score this points-wise. It still seems skinny to me. All right, so I would give you 1 point for the existence. I'd give you another point for this existence. And then I'd give you a point for this statement. If you didn't have all 3, you wouldn't get all the points. So just saying yes didn't really do anything. And I think when I was looking at the scoring guide, if you didn't say yes, you wouldn't earn the full 3 points as well. So you had to say yes and then answer the question explaining it, okay? Because it does say that we have to justify. All right, looking at this one, I'm going to give you a minute because you might not have that. I'm going to give you a minute to sketch it if you want. Okay, so part C, you can do without doing part A and B. And that's very common on the AP test that actually the 4 parts are not related to one another. It was very rare that what happened on our A and B where they were related to one another happens, okay? So this question is worth 2 points, okay? Because we're only getting technically 9 out of the problem, okay? So we're going to say that y equals g of x. That's very common. They gave the function. They're saying that y is equal to the function. We're going to say it's discontinuous at x equals 2. They also gave us a graph of g of x, which I did not. I erased the label on. This is g of x. Okay. State why this is true using the definition of discontinuity. So in order for it to be continuous, we know that the limit has to equal the value at that point. So I'm going to make a statement about the limit. So the limit as x approaches, we're supposed to be approaching 2 of g of x equals. So I've got to figure that out. So I'm going to go on the graph from the left and on the graph from the right, and I notice my limit is equal to 2. And I'm missing something on my graph. I apologize. Something got erased when I was doing this earlier. There's supposed to be a dot right there. All right, so now I'm going to actually go for what is the value of g of 2. So g of 2 equals, I am looking at 2, I'm looking for something solid. The only thing solid I see is that dot. So you'll notice that my limit does not equal, and I put a 2 and I should have put a 3, huh? Sorry, but it's up at 3. So you'll notice my limit does not equal my value at that point. So therefore, it cannot be continuous. Now I need to write that down in math words, right? So let's do that. We have that therefore g of x is not continuous, or you can say discontinuous. Both are they're interchangeable. At x equals 2, because the limit as x approaches 2 of g of x does not equal g of 2. As far as your points are concerned, you get a point for showing me 1 point. 1 point for that, for showing me those two statements, okay? And then you get a point for your reason here. And there's a typo on this, isn't there? That should have a g of x right there. All right, last part of this one. So we're supposed to find the limit. There's a total typo in here. It should look like that. I apologize because I published the one that has the typos in it, didn't I? I tried to just erase on the stuff I hand wrote yesterday, and apparently I erased too much on some spots. All right, this one, again, D is completely unrelated to the others. If you've been keeping track, it's worth 1 point, so I'm really only looking at the answer on this one. I'm not looking at any of the work in between. But I'm supposed to find the limit as g of x, or as x approaches 0 of g of x over f of x. So I'm going to go back to my graph g of x and c and my f of x function that I had originally. So, but before I do that, I'm going to kind of figure out, what does this mean? So this means that we have the limit as x approaches 0 of g of x over the limit as x approaches 0 of f of x. All right, so I'm going to go find the limit as x approaches 0 of g of x. I'm looking here at this graph. I'm going to look at what's going on at 0. So as I'm at the x value of 0, it looks like my y value is 1. Now I'm going to go to f, and I'm going to figure out which branch 0 goes into. Well, 0 is less than 1, so I'm going to put it into this branch here. So 3 times 0 plus 2. So I've got 1 over 3 times 0, 0 plus 2 is 2, so 1/2. Do you have any questions on that particular problem, any part A, B, C, or D? Let me know either on your microphone or in the chat. Okay, I have one more planned for us to do, because there could be some intermediate value theorem on the test, and I want to make sure that you are ready for that. Okay. This one isn't like a 9-pointer. This would only be like a 3-point question, if you're looking at severity of question points. So I'm going to give you a minute. If you need to screenshot it or write it down some way, I will be quiet for a whole minute and let you write. Okay, so we're given a table. There was actually a little bit more to this question than what I wrote down. Okay. So it actually was a scenario about a car. I just didn't feel the need to write all of it down because it really wasn't relevant to what we were doing, but you might have a little bit more there. They actually gave us another row to the table that was talked about acceleration, which will make more sense the further we get into calculus. All we needed for our particular problem was just what we call the velocity here. And again, we don't need to worry about that it's velocity. We just need to worry about that there's some numbers in the graph and we've got to use IVT to figure something out about them. So here's the scenario. The car travels on a straight track. During the time interval from 0 to 60 seconds, the car's velocity v, measured in feet per second, and acceleration a, measured in feet per second, are continuous functions. So we know that it's continuous. I wrote that part down for you, okay? Because in order to use IVT, that's the first thing you need to write, okay? Remember that. I might ask about it in a minute. The table above shows selected values of this function. So we've got selected values. Like I said, I left the a values off. So for the interval between 0 and 60 of t, not a big deal that we have a t, but it's acting like an x, right? It's in the x spot. What must there be a time when v of t equals -5? Justify your answer. All right, so whenever they ask this type of question, the answer is 100% always yes, okay? If it's no, then there's nothing for you to write down, really, okay? So it's always a yes is the answer to a question. But you have to tell me why, and that's the more important piece of the question. So what's the before I can apply mean value, or not mean value, intermediate value theorem, what's the very first thing I need to write down? Tell me in the chat. What do I need to write down? I've got one person who knows. Do we agree with her? One person agrees. Two people agree. Three. We're finally waking up. That's good. Okay. I should have seen everybody type it's continuous. I even told you ahead of time I was going to have you type that. You could have had it sitting there ready and waiting. Okay. So yes. So we want to say something like, since our function v of t, right, is continuous, the IVT applies. You may abbreviate IVT. It stands for Intermediate Value Theorem. And I might be writing this slightly differently than I did in the notes, but it works either way. You can follow the notes structure too, okay? So I basically need to prove to myself that when I put 0 in and I put 60 in, that those y values surround this y value. So when I put 0 in, my y value is -20. When I put 60 in, my y value is 10. -5 is definitely between those two values. We always use the endpoints that are given, okay? We don't need to worry about any of the other stuff in between. So I'm going to make a statement that says what we just talked about. So we're going to say that v of 0 equals -20. All I did was write down what we saw there, okay? And then I know that v of 60 equals 10. And then I know that this guy here is sandwiched in between them. So you have now proven to me that you understand that my y values are going from -20 to 10, and I get every single thing in between. Okay? Now we're going to say, therefore, IVT guarantees that there must be we're going to say a t, but sometimes it's a c value. That's how we were saying it in some of the notes. A c or a t on the interval. So my interval is 0 to 60, such that all I did was basically copy this, but instead of writing it in inequality notation, I wrote it in interval. I can still write it in inequality and it would be acceptable. Such that v of t equals -5. All right, are there any questions, comments, concerns about that? All right, we've got around 10 minutes, okay? Are there any other questions that you guys ran across in the actual review assignment that I put out there, because I know some of you did start it, that you want me to go over with you? I'm going to go on the microphone or put it in the chat. Is that Robert? Robert, what's wrong?
On the graph for me, I just can't find you know, the first question
on this one, or on the other review?
On the review.
Okay, I'm going to get there. Go ahead and talk while I get there.
So I can't I don't know. So I can't find a like f of -5. Like I'm at f of -5, and
Okay.
I keep putting does not exist, or I put like 5, but I can't really find the answer. I'm just confused, to be honest.
Okay. What item number was it? Do you know?
It's item number 1.
Item number 1. Okay. So now tomorrow on the test, everybody, if you're stuck on item number 1 and you don't make that so you can't do the whole rest of the test, okay? All right, so negative, so we're looking at just this first one, is that right, Robert?
Yeah, that's
Okay,
the only
so
one
the
I had
first,
trouble with.
what was that?
That's the only one I had trouble with. I found the other ones, but not that
Okay,
one.
you found the other ones. All right, so I am looking for -5. So -5 is right here, right? So I'm going to count 1, 2, 3, 4, 5. I'm going to trace that up. I'm going to read the y value off the graph, which looks like a 6.
Oh, I put 5. I thought that was a 5.
Yeah, count the number of dots. So 1, 2, 3, 4, 5, 6. Okay?
Okay.
It looks like it's scaled in 2s, and I know that's a really bad picture. All else fails, count the hash marks. Make sure that they're scaled in 1s, but count the hash marks. I will almost always scale in 1s. I don't like doing it in other things because it's confusing.
Okay. Thank you.
Okay, sound good?
Yeah.
You're welcome. All right, who else has questions? I got a few minutes.
The warm-up problem, number 1. I don't know how you find C.
Okay, so the warm-up problem today, Mason?
Yeah.
Okay,
Yeah.
Let me go back to that. I got to look at it again because I don't remember it. I only wrote it like, I don't know, 2 hours ago, but I don't remember it. It's rough when you get old. All right, so we're looking at, yeah, I know. Who's the first one, right? Okay, so this one right here, Mason, is that right?
Yeah.
Okay, I'm gonna really quick screenshot it and make it somewhere where I can write on it. Copy. All right, here we go. Oh, that didn't come out very big, did it? Okay, that I think is enough of it for us to be able to do it. So what we're doing here, we're supposed to be finding it continuous. And this is one of those questions that the College Board 100% loves. I kind of like them too. So that's kind of a really good hint. There's going to be something like this on the test. It might not be this exact equations, but there's going to probably be something like this on the test. This is a good one to show continuity, okay? So it's a good one to ask about. So good pick, Mason. All right, so I'm going to take, in order to be continuous, I know I have to be able to plug that number into both of them. And I know that both my right-hand limit and my left-hand limit have to be equal. Technically, what I am trying to do is show the limit as x approaches 9 of x squared equals the limit as x approaches 9 of c of x. We're going to use direct substitution on that limit. So I'm going to take and I'm going to plug in the 9s into both of those. So we'd have 9 squared equals c over 9. 9 squared, I believe, is 81 equals c over 9. And then I'm going to multiply both sides by 9. So I believe that's 729. Is that better, Mason?
Yeah, that makes sense now. Thank you.
Okay. It's like the silliest thing ever, right? Set them equal to each other and plug in the number. That's the easy way to explain it without the calculus behind it. But I want to make sure you understand the calculus behind it too. All right, what else, guys? Okay, so I'm looking at the chat. 10, 11, 3, and 12. Okay, so let me start there. We'll see how far we can get in the next, 6 minutes. Okay? All right. So I'm going to go that way. I'm going to go back to drafts. I heard somebody. What's wrong?
Oh, Miss Ballard. When the limit is equal to infinite, like infinity, what is it? 1? Is it technically equal to 1 or no? Like,
say that one more time.
If the limit is equal to infinity, like y to infinity, is it y to 1 or no? Like does it?
So if the x value is going to infinity?
No, it's the y. It says y to infinity on item 10. I'm looking at it at the.
Okay.
phone.
So it's on item 10. I'm going to get there in just a second. Okay.
Okay.
Give me a second to look at it. For those of you that haven't observed me over the past few years, I'm the kind of person where I actually have to see it. It drives my daughter nuts. She wants to read me all of her problems, and I have to actually see what I'm looking at. So sometimes if I say, hey, wait a minute, that's what I just have to visually see it. But I see what you're looking at now. It says that y is approaching infinity, right? And it's goofy because it says y, and we aren't used to it being y, right? We're used to it being x. I kind of did that on purpose because sometimes they give us a variable that's weird, all right? So let me screenshot that one real quick and pull it in. I'm going to copy it and put it over here. All right. Let's see what we got. Oh, we got enough of it. All right. It's really tiny, but we got it. Let's see if I can make it bigger. There we go. That's better. All right. So when we're approaching infinity, remember there's three things we have. If the exponent on the top, okay, is smaller. So exponent on top is smaller. And there's a chart, right, in your notes. The exponent on top is smaller. That means it's growing faster on the bottom than the top. That means your limit equals 0. Okay? If your exponent on top is bigger, that means your limit it's growing without bounds, right? It's going to be infinity because your top is growing bigger than your bottom. If your exponents are equal, which is this case we actually have here, believe it or not, okay? Then your limit is going to be the coefficients, and I know my handwriting is terrible right now, in front of biggest exponent. Okay, so let's take a look at this one. If I am putting infinity into this thing, infinity is a huge number. These two numbers here are going to become extremely insignificant, okay? So it would be a very, very insignificant number. So they basically kind of go away, which means I am left with negative y over the square root of 6y squared is kind of what I can estimate my limit to be, or estimate my function to be at infinity. Remember when we did like the approximately symbols in like elementary and middle school because we were estimating things? That's kind of what we're doing with this limit. Well, I know that I can also take the square root of y if I'm going to go that far to estimate this. So I've really got negative y over the square root of 6y. All I need to do, because now my exponents are both 1s, so all I need to do is take my coefficients in front, okay, as my limit. So that would mean my limit, technically there's a 1 on the top and a square root of 6 on the bottom as my coefficient. The only thing that might change that up is if, say, I put a negative infinity there, it would change the sign. So if my sign is opposite, I might have to change my sign. Okay, does that make sense? Robert, did I get your question too?
Yeah. Oh yeah. So infinity equals 1, right? Or am I wrong? Or
Infinity equals, it depends on what's there. It depends on it depends on these exponents. Okay. Okay.
Mm-hmm.
All right.
So
let me look up. Let me grab 11.
So why do you cross 2 and 8?
What's wrong, Robert?
Oh, so you can take out 2 and 7 out the problem?
Only because of the nature of the problem, because it's approaching infinity. 2 and 7 are insignificant at that point.
Okay.
Right? Because they're not going to, 2 and 7 are not going to do anything to change our mind about what infinity is, right?
Mm-hmm.
So that's why. Okay?
Okay.
All right, here we go. We're going to do the next one, 11. So here's 11. So it says the limit as x is approaching 2. I technically probably need to go into both. It says, even gives me a hint. It won't give us the hint tomorrow on the test. Test from both the left and the right. So we've got the limit as x approaches 2, and I'm just going to go ahead and sub into the top one. 2 squared minus 3 times 2 plus 6. So we've got 4 minus 6 plus 6. Those are going to cancel. I got 4. The limit as x approaches 2, I should have really written left up there, from the right of negative parentheses 2 squared plus 3 times 2 plus 2. You got to be careful on this. Okay. This is 2 squared. This negative is not part of the squared, so the negative stays. My guess is that's probably where the mistake is. Plus 6 plus 2. So I'm seeing -4 plus 6 is +2 plus 2 is 4. So my overall limit would have been 4. Okay. It says number 10 is wrong. I don't know. I'd have to go in. Brianna, I'll go in and look at the answer, but I know that what I did was correct. Other than maybe I have a weird sign mistake somewhere. That's the only thing I can think of. The sign should have been okay though. I might have to just put it, try, Brianna, try and see if, try it without the negative sign. See if I made a sign mistake. Okay. All right. Number 3 is what I'm going to go to next. All right. So here we go to number 3. We still got this guy here, that picture. Okay. Answer the following questions. So we've got the limit as x is approaching 0 from the left. So I'm on the 0 is right here. I'm on the left side of 0. Notice the y value is going down, 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 down to -infinity. Does that make sense, Casey? I know you asked. So it should be -infinity, and you should be able to type in the little symbol there. It's right here on the. Are we good, Casey?
I tried typing it in, but then it was saying that it was wrong.
Negative. I'm going to try it too. Infinity. Sometimes I'm learning the system, so sometimes I'm not inputting it the right way. Hang on. Oh, you know what? There was one that was acting weird yesterday. This might have been it. My view is all messed up. Go back, go back, go back. I zoomed too much. Let's check it out. Oh, where's my check answer? My check answer button's not showing up. It's possible there was one. I put it in the stream yesterday, so check the stream. That might be the one that was checking wrong. Okay, but it is -infinity. Okay. All right. I know the bell just rang, but if do you guys want me to do 12 and 18 while I'm sitting here?
Yes, please.
So let's put it this way. You are welcome to leave. If you want to stay for me to do 12 and 18, I will do those really quick before I turn on third period, because technically it's passing period right now, right? So, all right. So, oh boy, what happened? I'm going to just close out of this and go in there again. I apologize. I zoomed really weird and it's acting dumb. We don't want it at 50 though. We want it more like at 100. Okay. Give me a second to get back there. We are looking at assessments, and I am looking at Calc, Unit 1, Preview. And I'm going to go to number 12 once the Start button comes up. Okay, so this one here, we're going to have to factor it. Okay, so let me take a screenshot of that one real quick so I can get to somewhere where I can write. Okay, so it tells us that A isn't going to be equal to 0. Okay, so I'm going to go ahead and factor this. It's a difference of squares factoring. It just looks kind of weird. I'm going to leave the numerator alone, actually, and I'm just going to factor the denominator. The good news is I can put something easier than this on the test. So I give you the hard one in the review. I can make the test a little bit easier. When you do difference of squares, they just have to be evens here, or square numbers. So I'm going to take the square root of x to the 4th, which would be x squared in both the fronts. Square root of a to the 4th would be a squared in the backs. Make one a plus and one a minus. Then you'll notice that these two cancel. So now I have the limit as x approaches -a of 1 over x squared plus a squared. I'm now going to use direct substitution and substitute this in. This is a little bit different than the negative we had earlier. Okay? Negative, and it looks like a 9, it's an a. Negative a squared in this case, because it's inside parentheses, this time the a would turn positive. So I have a squared plus a squared, or 1a squared plus 1a squared, which is 1 over 2a squared. Okay, and it looks like I need to do 18. Oh boy, that one looks like fun, doesn't it? All right, we will do this one. This is one of the challenge problems. you really should technically know how to do this, okay? If you got my email saying, hey, you're going to take the challenge part of the quiz, I would make sure that I know how to do this one, okay? There's a few of you that got 100%, so we're not going to make you retake the same thing because you've already shown me you can do it. Okay, so might as well let's try this one. So what I'm going to do, oh, it should have had a 0 there. There's a typo on that. It should have been x approaches 0. Okay, I apologize on that. I mistyping something because I couldn't put 0 in the denominator. I am going to, this squared thing means I need 2 foils, so I really need to multiply x plus delta x times x plus delta x. So, and I'm going to go ahead and write that in my thing here. I'm going to put my delta x on the bottom. So x times x is x squared. X times delta x is x delta x, but I have another one in the middle, so I have 2x plus delta x. And then delta x times delta x is delta x squared. I'm going to distribute that 2, so I get negative 2x minus 2 delta x. And then I've got a 1. And then I'm going to distribute my negative. So negative x squared plus 2x minus 1. All right, what should happen if it's set up correctly, Mrs. Ballard didn't mess up, is all of the variables that don't have a delta x should cancel. So x squared goes, 2x goes, and 1 goes. All my signs are opposite, okay? And I am left with the limit as delta x approaches 0 of 2x delta x plus delta x squared minus 2 delta x over delta x. Notice that there is a delta x in each one. That means I'm going to factor out a greatest common factor of delta x. So we've got the limit as delta x approaches 0 of delta x times 2x plus delta x minus 2. I have 1 left in there, right, because it was squared. The bonus here is they cancel, right? That's what we were looking to do. And now I've got the limit as delta x approaches 0 of 2x plus delta x minus 2. I'm going to plug 0 only in for the delta x. So I get 2x plus 0 minus 2, or 2x minus 2. Okay? Sound good? All right. I will see you all tomorrow. I will make sure I put texts out there letting you know when I have everything open. Okay?